Hello everyone, and let's talk about how we're going to perform our first home-based lab this semester. So all of you have these two pieces of equipment in front of you. The first one is the multimeter, digital multimeter, which is essentially exactly the same as the ones which we are using in the lab, or maybe you do actually have exactly the same one from the lab. But if you have these red ones, they're just smaller versions of the big ones which we are using in the lab. And then we do have something which is called Breadboard, and it's a very easy device which allows us to quickly connect the resistors together into something which we call DC circuits or AC circuits, depending on what power source you are going to use. Today we are going to connect these three resistors in this triangular fashion, in triangular ring fashion, and the goal of today's lab is going to be to measure individual resistances of these three resistors based on the measurements of the equivalent resistance between a few specific points of our circuit, which is represented by a circuit diagram in your advanced sheets. So let me turn it around this way so it looks a little, well, actually this way, so that it looks very much similar to the diagram which you see in your advanced sheets. So if you compare this circuit to the diagram, you are going to realize that this is our point A, this is our point B, and this one is our point C. Well, the resistances are resistor R1 here, resistor R2 here, and resistor R3 here. So we're going to start by looking at our chart, color chart diagram, and find the equivalent resistances, the nominal values for the resistances of these three resistors. One reason why we want to do it is, of course, to compare our experimental measurements to them. And then the second one is just it makes it a little bit easier to decide what range should I use when I measure or set up my multimeter. I'm going to let you do this part yourself, but from just looking at the colors, I can say that my resistors are all in the hundreds of ohms, hundreds of kilo ohms range. So I will set up my multimeter. And first of all, I'm going to actually turn it on like this. And then I'm going to set my multimeter to the range which corresponds to 200 kilo ohms. And I'm fairly confident that all my measurements are going to fit in that category. So once you have your multimeter set, all you need to do is take the multimeter and measure the resistances between three pairs of points. So just as we know that this is A and this is the point B, so the very first thing which I will do is I'm going to measure the resistance between the point A and point B simply by pressing my multimeter to these 2 points here. And my multimeter, you cannot really see it in the video, but multimeter tells me that the resistance between these 2 points is equal to 180.8 kilo ohms. So this is my resistance, or AB, and I'm going to record it in the table provided and move to the other couple of points. This is, remember, A, this is B, and this is C. So I'm going to now measure the resistance between the point B and C, and that's what we call our BC in the lab manual, in the advanced sheets. And my measurement is 136.2 kilo ohms. This is what my multimeter is giving me. Once again, I'm going to simply record it in my table. And then finally, I have one last pair of points to work with. And this is the resistor between point A and C. So I'm going to measure my resistance by pressing my multimeter to these 2 points, and I find that the resistance is 154.3 kilo ohms. Now, at first glance, you would probably think that this is the actual resistance of my resistor right there, but it's actually not true, because when we measure the resistance between these 2 points, we actually measure the resistance of the entire configuration of the resistors, which, by the way, given that we are measuring between these points, corresponds to resistor R3 and a resistor R1 in series with each other, which is connected to the resistor R2 in parallel. So this is the origin of the equations which we see in the advanced sheets for the lab. So given that I measure the the resistance between points A, B, like this, now I'm measuring, once again, the resistance of a combination of resistors in which resistor R3 is connected in parallel with resistance R1 and resistance R2, which are connected in series with each other. So each of these 3 measurements which we performed are in fact the equivalent resistances for the parallel/series combination of resistors, and this actually concludes our experimental part. Is just that quick and easy. So what we are going to do next is we are going to take these 3 equivalent resistances which we measured, RAB, RAC, and RBC, and use them along with the equations which you find in the advanced sheets to find the individual resistances R1, R2, and R3. In order to do so, you can definitely solve these equations by hand, although it is not all that trivial. So the easiest way to do it is to use some kind of automatic equation solver. And one of the suggestions which I have for you is listed in the advanced sheets. By all means, go ahead. Now, my practical advice to you is to have the equations, open up the equations, and substitute x, y, and z, just to make it a little bit simpler to deal with, instead of R1, R2, and R3. So everywhere you see R1, you just write x. Everywhere you see R2, you write y. And everywhere you see R3, you plug in the z. And then, of course, you're going to put in your 3 measurements for RAC, RBC, and RABC. AB, BC, AC, and these resistances, the actual ones which we measured here, will go directly into these equations. Once you have the equations set up, you will enter them into the equation solver, and it will give you the individual resistances, your X, Y, and Z, which of course are R1, R2, and R3, in really no time, in a matter of seconds. So once you have your measurements performed, and once you solve your equations, the interesting part of it, of course, is to compare the actual resistances which you found to the nominal ones. Now, all these 3 resistors have the tolerance represented by the gold band, which means that I expect the nominal one and the actual resistances to be somewhere within 5% of each other. And I want you to look that up, and I want you to see if the values which you have obtained from the equations are indeed within 5% of the within the nominal values. We're not going to calculate the percent discrepancy in this lab, just because we really do not have a good accepted value or measured value for the resistances. All we have is the nominal, and we know how different it could be in principle from the actual resistance. So what I want you to comment in the conclusions is if your measured values which you have gotten by means of solving the equations do come within 5% tolerance with the actual with the nominal values which you find from the color bands. Okay, so this is it. Now for this lab, I do not request the Excel spreadsheet, simply because we really not going to perform any of the calculations. Although you may want, if there are 2 ways in which you can approach it. You can either turn in the data sheets with your measurements, or alternatively, you can create the Excel spreadsheet in which you enter your measured values, your nominal values, and it's either one or the other way will be absolutely fine. And on top of the data and of course your solutions, you are going to include the sketch of the apparatus with the capabilities, as we typically do, and then results and conclusions. And the best way to find what I want you to comment on or to include, as always, is the advanced sheets. Please use them. And that's, guys, it. Thank you very much. If you have any questions, feel free to send me an email.